Hi, this is Team C3375B, and we're the first all-girls team to make it to nationals for New York State. My name is Angelica. I'm a sophomore. I'm also in mechanical, and I help build Robot B.
Hi, my name is Cheyenne, and I'm a junior, and I help program Robot B.
Hello, my name is Gabrielle, and I am the co-captain of this team. I am a junior, and I help build Robot B.
Hi, my name is Jasmine. I'm a sophomore. I'm a mechanical, and I help build Robot B.
Hi, my name is Mariah, and I worked on the electrical and on the book, and I'm also a sophomore.
Hi, my name is Ashley. I'm the captain of the robotics team, and I worked with computer programming as well as recording in the engineering notebook.
The most difficult task with this robot would have to be the rack and pinion and the hang. Originally, this was not the design. It was a diagonal rack and pinion that would make it hang, but there was not enough power or it did not reach the pole at all. There was also the problem with the turning of the robot because the turning wasn't smooth, but now it's smoother when I realized that one of the motors was in the wrong place.
Also, another difficult task we had building the robot was these two front wheels. In the beginning, they were a great idea for pushing stars under the fence, but as we realized after a couple matches, they kept loosening, so we had to find a great solution as to keeping them nice and intact the whole time.
Stars also would get stuck under them.
I consider the strength of our robot to be the hang, because by our hang we could do a low hang, and that low hang can gain us some more points. And also the hook for the hang we used it to push stars over the fence.
I think to improve our robot, we could have make it a high hang because right now it's a low hang, and strategizing more on pushing stars to gain more points.
A big part of our journey has been community outreach, especially at Barnes & Noble's that was closing down. We went there and we spread our engineering awareness, teaching kids about gear trains, how to build robots, and just a little bit of what we do. It was a great learning experience, and we would love to do more community outreach.
Now we will be talking about some parts of the robot. So this robot in total has 6 motors. It has 4 on the top and 2 on the bottom powering the 4 wheels. So this specific motor over here powers these 2 gears that mesh together to lift the hook. And then these 3 motors are here to push the rack and pinion up for the low hang.
We use 393 motors because they are the most reliable. So here are some of our gear trains. As Gabby said, we started off with a vertical rack and pinion design. Here are some more pictures. Now on our robot, we have these gear trains that Mariah drew. All of our gear trains were 100 revs per minute, which equals a 1-to-1 ratio, and a 1.67 torque, which is very strong and good. Here are some more gear ratios. As for the programming, so basically for the autonomous program, what we wanted to do is push stars under the fence, then move backwards and try to get it hanging. That is our main goal, is to get a high hang. Right now we're a low hang. And as I said about our community outreach at Barnes & Noble's, here are some pictures of all the girls. This was a robot from Barnes & Noble's that we helped program, and it was a very fun experience because it did different activities and the kids really liked it. Here are some more pictures of the girls building Legos. They were also driving around with clawbots and picking up things. Yeah.
Another great addition we added to the robot was this rod in the back. It helps push stars under, and it hovers so we won't get in trouble for going under the fence. So now we will be demonstrating the low hang for Robot B. and that's the low hang for robot B.
Now I would like to talk to you a little bit about the CAD CAM that we have been working on Autodesk Inventor. So this is the Autodesk Inventor CAD CAM for Robot B. As you can see, here's the lift and the rack and pinion and its driver wheels. This was inspired by this drawing of Robot B. This is the schematic for it that we used. So here are just all the gear, trains, and what we had to trace it on. Some of the hook, rack and pinion.
In this program, we also utilize the X, Y, and Z axes for drawing the lines. We also used this 2D sketch mechanism so that way we can get very precise measurements within this. We also separated everything into separate parts. So part 1 would be the chassis square, part 2 would be the wheels, part 3 would be the innermost square, and part 4 would be the rack and pinion. So that way it would be easier for us to keep everything more organized as well as paying attention to the precise measurements as well.
So something else that we worked on was the 3D printer. Unfortunately, we had a couple of problems with the heat and it didn't work out so well, but this was supposed to be a claw. As you can see, the bottom is melted, and hopefully in the future we would like to work more with the 3D printer and have a successful print. But that was done with Cubify Pro.
Also, this video is for the VEX Create US Open at Nationals.
Here's some pictures, like I said, of Robot B. And that helped us make this design.
Also, I forgot to add that every time they rebuild the robot, I had to change the map for the gear ratios.
Here's some of our gear ratios. As you can see, here are all the teeth that the gears have. Here are the motors, and that's the math that we did to get the RPMs and how fast it would go. Thankfully, all of our gear ratios have worked out and are successful and are very good.
What makes our team unique is that we are the only all-girls team competing at nationals and that we like to empower young women to become more involved in STEM.